This is Module 5, Part 2 of the Foundations of Programming with Python video series. So far we have seen quite a number of sequences or collection types. We covered string, tuple, range and list. All of those store data in a sequence and are accessible via an index or substrate. In this part, I'm going to be introducing dictionaries. Dictionaries are mapping types, and they are similar to sequence types, but replace the index and storing in sequence by storing key value pairs. So this means instead of using an index, the programmer defines a key under which the values are being stored and accessed. Dictionaries use the curly braces operator, and the full syntax is a key value pair. So if I'm going in here, so a dictionary is curly braces, and then we have a key, colon, and then the value. Of course, going to be screaming at me because key and value, those variables are not defined. So what I actually can do is I can simply define them as strings for now, for example. So now I have the string that holds key is my key, and a string that holds value is my value. If I have multiple values, I'm simply separating them with a comma, and then add my second key and my second value. So this is how you're creating a dictionary. So demo. Now it is created. I can let show what is in there, and accessing of individual items is like this. So we are using the square brackets to indicate which key we're asking for, and this returns the value that is stored under this key. So let's have a look at the documentation. The keys can have any value that can't be changed. That is immutable. So perhaps it's easier to look at this backwards. The types that can't be used in dictionary keys are objects that you can change, like for example a list. So you can't use a list as a key, but you can use tuples, strings, integers, constants that you have defined. All this works. And if you're using tuples as key, the limitation there is that the tuple can't contain, directly or indirectly, anything that is changeable. So you can have a tuple with strings in it, or strings and integers in it, that is all not a problem, but you can't have a tuple with a list in it. You also can have a tuple that has a tuple in it as one of the elements, and then again, as long as there is not changeable objects in there only. If we are storing, I'm going to be showing this here. So if we are storing we also can add actually elements to the dictionary, just like this. Key 3. Value 3. So now, if I'm calling this, you actually see that this value has been appended. Now I can now if I'm storing on key value 4, what actually happens is, because this key exists in the dictionary, it is updating this value. The original value is getting overwritten, replaced by this new value. So this is a value assignment under this key. Every key has to be unique in a dictionary. So by accessing or assigning a value to a dictionary under a key, adds it if it does not exist. If it exists, it updates the existing value. So let's have a look at a few built-in functions that are specific to dictionaries. If we are asking or casting a dictionary to a list, then we are getting a list of all keys that are in the dictionary. If you're running the function lang on a dictionary, we are getting the number of items in the dictionary. We have already seen that, we have played with this. If the key is not existent when we are asking for it, then we're getting a key error. If we are assigning a value to a dictionary with key, then we're setting this dictionary key to the value. We also can remove a key value pair. And this one here is very handy. It returns true if D has a key, otherwise it's false. Clear removes all items from the dictionary. We are probably not going to be touching the iterator that soon. Then we have the items. It returns a new view of the dictionary's items, so key value pairs. Then we can have returned the keys. It's returning a few of the dictionary's keys, so this is something different than asking for the list. We're getting a different result. And then we have also this function here with the values. It returns a few of the dictionary's values. So let's have a look on this in action. You can think of the keys in a dictionary like the names in a table, so the header names in a table. If you're creating a table, you're putting a header in there. Going back to our 3D example, you actually would have, if you're creating it as a table, as a spreadsheet, for the artist, you actually would put a header artist in there, and you would be putting the title for the CD in there as a CD title or a title. And these keys in a dictionary you can consider those headers, those named headers. So that perhaps helps visualizing what is happening here. So let's have a look at these individual functions in a dictionary. So I'm creating a dictionary, and as you can see, the values are mixed again. I have integers in there, I've got strings in there. I'm simply printing out the complete dictionary. I get what we have already seen. Then I can access the individual ones with the dictionary name, dictionary email, dictionary ID. So this works as we have already seen, as expected. Here I'm going to be exploring a few methods that we touched on. So when running it, I'm declaring two dictionaries, and then I'm creating a list table that holds those dictionaries. It's a list that holds those dictionaries. So it's a list of dictionaries. It's a 2D data construct here. Looking at this with the items in list not formatted at all, so I'm simply printing out the list that is holding the dictionaries. This is what we are seeing here, so not formatted. This is this output over here. So we actually see the two dictionaries as elements in the list. Then going through each row, and I can print the row out of as the elements of the list, and I'm just getting the dictionary, just in quotation marks here, one after the other, unpacking them with the item function. So for each row I'm doing the unpacking. I'm repeating the row that we can see what is happening over here. And then I'm actually getting key and value out here for row items. Remember the unpacking of tuples? This is exactly what is happening here. And then I'm printing out the pair. So unpacking with the item function. So we are unpacking this first dictionary, and we get the key value pair, ID and 1. Then the next key value pair is, we're getting name, Jane Doe, email, janed@domail.com. This was the inner portion here. Now, because we're going through each row of the list, we're actually going a second time through the outer for loop, and we are unpacking the second dictionary in exactly the same way. Next is displaying only the values with values. So for each row in list table, which returns the dictionary, I am simply printing out the row values. So this is this portion here. We see the dictionary here, and printing the values returns a list with the values. We lost the key completely. We're getting a list of the values, like the list that we have seen before. And we also can just display the keys. So keys, and then this is the dictionary that we're processing, and then we actually get the keys as elements of a list. So this is just to demonstrate some of the functions. And same as with lists, dictionaries are mutable, so you can change them. You're not creating a new object, so it is actually changing at the same memory location. It is not creating a new one. And this is what we're going to be demonstrating here. So let's run this. So we can assign directly into the dictionary. So if I'm entering an ID, I'm entering a name, so that would be chain Fox, and an email, that would be chain F. And what I'm doing here is, and I'm going to be demonstrating that it is actually the same result. So the result is the same. We're getting the same formatted dictionary, but what I'm doing is a little bit different. So this one here, I'm directly assigning into the values of a dictionary out of the input function. And here I'm first gathering the strings of the input function, then I'm processing the ID to an integer. Remember, we are saving the ID as an integer, and it is actually saved as an integer in all 4 cases over here. You actually can see there is no quotation marks around the numbers, so it is integers. I did it here. In here I'm processing it individually, and then I'm creating this dictionary row, and then I'm appending it to the list. And finally I'm showing the result here. Both ways are possible. It depends a little bit on the team culture that you might be working in, if they're going to be kind of allowing this, or if they're frowning upon this, that you are doing the input and direct assignment into a dictionary, or if it would be more expected that you're first actually assigning it into a string, and then you're doing the final processing, and then you're creating a dictionary row in one go like this using the variables. Both is possible. Nothing wrong with either. It is just the preference of the group that you're working with that decides which one is more preferable to do. For this course you can do either. And of course, reading in data from a text file works as well. So we're going to be using again the metadata file. We have already 2 rows in here. We have an empty row. Again, we are saving it in a list table. We are appending the list table with the first 2 dictionaries. And if we're running it, what we're going to be seeing is it's first demonstrating us what we have in the list. Then we are loading the data from file, so we're opening the file, we are creating a list, and then we're creating a dictionary out of the list elements. We are appending the data to our list table, this dictionary. We are appending the row, dictionary row, as a row to the list table. We are closing the file, and then we are printing out what we have. this is the result here. So yes, we are getting a double of this IDE 1, which is perfectly fine, and it is what a list can do. And because we're reading in the data that we already have, we're getting a duplication here. It actually shows that it worked. With this, we're getting to lab 5B. In this lab, we're going to be modifying the code from the last lab, and we're modifying it in a way that we're using dictionaries for the rows. So we're creating a list of dictionaries, same as in this example. We're going to be using this construct for a 2D data structure for what we did in lab 5A. So running it, we are actually getting this, and so this is, as you can see, I'm working with dict rows, so I can read the data, I can display the data, and I can add. I'm doing a duplication here. Yeah, duplication with spelling mistakes. So we actually can see with my spelling mistakes that we have an additional data set here, and if I'm writing it out, then I'm copying my spelling mistakes into here and I'm fading it. Yeah, perfect. And I can exit out. And the solution is using dictionaries for the inner structure and the list for outer structure. Now I have an example that is a bad example, and I'm going to be reading in the data, I'm going to be displaying the data, and this is the fourth part. Have a look at this and show what is or why this is a bad example, how not to do it. This is lab 5. With this I'm concluding part 2 of module 5 of the Foundations of Programming with Python video series. See you in the next part in a moment.